Welcome and thank you for joining. We'll continue with question number 8 from the thinking question set. Remember that we are reviewing for unit number 2 test, which is about derivatives. So in this question, we have to find the equations of two tangents to the graph f of x equals x squared minus 1 that pass through the point 1 and negative 4. And then we have to sketch the graph and the tangent lines. So just to create a general idea of what we are dealing with here is the graph of the function f of x equals x squared minus 1, which is a quadratic function. So the graph of it is a parabola with a vertex at x equals 0, y equals negative 1. So from a point on the Cartesian plane, coordinates 1 and negative 4, we are drawing tangent lines to the graph, and as you can see, we can draw two tangent lines from this point onto the parabola. And we are trying to find the equations of each tangent line. Now, as you can see, the two tangent lines will have different steepness or different slopes and different y-intercepts. So the graph are not to scale in here, so we don't know exactly where the y-intercepts will be, but this is a general a sketch of the tangent lines. So we're going to get started by writing the equations that we are looking for. So we're looking for an equation in the form y equals mx plus b that will represent the graph of this tangent line, and the equation of y equals mx plus b, the blue tangent line. So in order to find the slope of the tangent, we need to look into the derivative of the function. So we know that the slope of a tangent, derivative of a function, means the same thing. And in our case, we have f prime of x equal to 2x. So 2x will be the slope of the tangent at any point on the parabola, including the 2 points where the two tangents are passing through. So what that means again is that if x equals, for example, negative 2, then by substituting x by negative 2, we can find what the slope of the tangent will be if you were to draw a tangent line at x equals negative 2. Same as if you are trying to draw a tangent at x equals 0. That means that the slope would be equal to 2 times 0. As you can see, the slope would be 0, and so on. So the slope of the tangent can be equal to 2x, or we can use 2x to determine the slope of the tangent at these two very specific points. Now, as you can see, because we don't know exactly where these 2 points are located, our job will be to find the coordinates of these 2 points. And the way we have done this in the past is by expressing the slope of the tangent in two different ways. So one way would be by using the derivative of the function, and another way would be by using the delta y over delta x formula, which gives us the slope of the tangent drawn exactly from point 1, negative 4 to a point on the parabola. So in this case, then, we're going to say that the slope of the tangent can also be interpreted as delta y over delta x. Now, let's take a look at what would make delta y and delta x in our case. So we're going to call x1 and y1 the coordinates of the given point, and the coordinates of the point of tangency would be represented by any value of x, because we don't know what that is exactly, and the y value would be equal to x squared minus 1. So what that means is that we can treat these two coordinates as x2 and y2. So by using the delta y over delta x formula now, we can determine the slope as, so here we go, we have y2 minus y1, or in other words, x squared minus 1 minus negative 4. So I will write out the formula first because it makes it clearer and easy to follow the solution. So we are substituting y2 now by x squared minus 1. Subtract y1, which is negative 4. And for delta x, we have x2, which is simply x subtract positive 1. So simplify this, and we obtain the slope of the tangent as x squared. Now we can quickly simplify here. Negative 1 minus negative 4 is negative 1 plus 4. So that will make a plus 3, and x minus 1 is in the denominator. Now remember that 2x will represent the slope of the tangent at any point on the parabola, and x squared plus 3 over x minus 1 will represent the slope of the tangent drawn from the point 1, negative 4 onto the parabola. Now, because we are talking about the same tangent lines, it means that these two slopes must be equal in value. So what we're going to do next is equate 2x with x squared plus 3 over x minus 1 and solve for x. That will allow us to find the coordinates at the point of tangency. So we have a quadratic equation that we have to solve here that involves a rational expression as well, or we should say a rational equation that involves quadratic expressions as well. And the way we like to solve these type of equations is by cross multiplying. That's the easy way, but cross multiplying, remember, is a shortcut for multiplying both sides of the equation by the lowest common denominator, which is in our case x minus 1. So cross multiplying would look like this, and remember that it is useful when we want to quickly solve a rational equation only if we have a single rational expression on each side of the equation. So here we go, we have 2x times x minus 1 equals x squared plus 3. So this would be 2x squared minus 2x equals x squared plus 3. Let's continue solving this. We'll take all the terms to one side of the equation. So we have 2x squared minus x squared minus 2x minus 3 equals 0. Let's hope that we're going to get nice numbers in here. So here we go, we have x minus 3 and x plus 1 as factors, which would give us the values of x at 3 and at negative 1. So don't worry, we're almost near the end of the solution. So it seems that the points of tangency will be at x equals negative 1. So it seems that we are right on the spot here for this point, and at x equals positive 3. So that would be about a little bit higher in here for the blue parabola. So I'm going to call this point of tangency, the green one, point A, and the coordinates of it would be negative 1. And let's find the corresponding value of y. So remember, the y value would be the value of the function at 3. And the value of the function at 3 would be 3 squared minus 1, or 3 squared minus 1, which is 8. So that means that one point of tangency would be at x equals 3 and y equals 8. And the other point of tangency would be at x equals negative 1, y equals, let's see, negative 1 squared minus 1 would be 0. So negative 1 and 0. So now that we know the coordinates at the points of tangency, then we can find the equations of each tangent. So what I'm going to try to do in here is try to minimize this because it seems that we ran out of space. So let's quickly do this. And here we are. And we are going to continue now with finding the equations of each tangent. Now remember that we have the coordinates of the point of tangency. So for the first one we have negative 1 and 0, and for the second one here we have the coordinates x equals 3 and y equals 8. Now if you want to find the equation of the tangent, it means that we need to find the slope and the y-intercept. So we can easily find the slope by using the derivative formula. We can use either formula as a matter of fact, because both 2x and x squared plus 3 over x minus 1 represent the slope of the tangent, but it is easier to evaluate the slope of the tangent from the derivative. So it seems that since y prime equals 2x, or slope equals 2x, then the slope would be 2 times negative 1, so we have the slope of negative 2. So in a similar way, we'll find the slope of the tangent for the second line. So the slope is y prime, and this time we have the slope drawn, or the tangent line drawn at negative 3. So at negative 3, we'll have the slope equal to negative 6. So far we have brought our equations in the form y equals negative 2x plus b, and y equals negative 6x plus b. So all we have to do is find the y-intercept for each tangent line, and for this all we have to do again is substitute the coordinates of x and y at the point of tangency. And let's take a look at what we get here. So here the y value is 0, the x value is -1, and we have the slope of -2, that's a given, and we are missing just the value of b. So -2 times -1, that will give a +2 plus b equals 0, so b equals -2. So equation of the first tangent will be -2x minus 2. And let's take a look at the second line. So we have the y value this time equal to 8. We're talking about this 8 here. And we have the x value equal to 3. The slope is -6. So all we have to do is find the coefficient b, or the y-intercept. So 8 equals -18 plus b, which will give the b a value of 26. No, wait a second. -6 is the value of the slope is +3. Made a mistake in here, so we're going to fix it. So that would give us the value of b equal to -10. And with this, we have created the equation, or found the equation of the second tangent line, and this would be 6x minus 10. As you can see from the graph, approximately we can say that the tangent lines are drawn with quite some accuracy, as a matter of fact. So let's double check in here. Yep, that's all. So I hope this made sense, and thank you for learning with me. Bye for now.